This is SpaceTime, Series 21, Episode 24. Coming up on SpaceTime, an ancient relic galaxy uncovered. Galaxies discovered to be spinning like clockwork every billion years. And proposals for the establishment of the United States Space Force. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers using NASA's Hubble Space Telescope have uncovered an ancient relic galaxy in our own cosmic backyard. The new observations, reported in the journal Nature, indicate that this rare and odd assemblage of stars has remained essentially unchanged for the last 10 billion years. The data provides astronomers with valuable new insights into the origin and evolution of galaxies billions of years ago. The galaxy NGC 1277 is a lenticular galaxy in the constellation Perseus and a member of the Perseus cluster of over 1,000 galaxies located some 240 million light-years away. Lenticular galaxies have an intermediate morphology, roughly about halfway between disc-shaped spiral galaxies and elliptical galaxies which are more ellipsoidal in shape. NGC 1277 began its life long ago, ferociously churning out stars through a process called starburst 1,000 times faster than seen in our own Milky Way galaxy today. These stars were formed over a relatively short 100 million year period of time, some 12 billion years ago. The galaxy then abruptly went quiescent as the formation of new stars ceased and its existing stars aged and grew ever redder. While Hubble's observed many similar so-called red and dead galaxies before, they're usually found in the distant early universe, appearing as little more than red dots on Hubble deep sky images. NGC 1277, therefore, offers a unique opportunity for astronomers to see one up close. One of the study's authors, Ignacio Trujillo from the Institute of Astrophysics in the Canary Islands, says exploring these ancient galaxies allows astronomers to probe the early universe. The new observations indicate that this relic galaxy has twice as many stars as the Milky Way, but is physically only about a quarter of the size. Trujillo says essentially NGC 1277 is in a state of arrested development. Perhaps like all galaxies, it started out as a compact object but failed to accrete enough material to grow sufficiently in size to become a spectacular spiral galaxy. Trujillo says about 1 in 1,000 galaxies are expected to end up as relics like NGC 1277. Astronomers aren't really surprised to find it, but simply consider that it was in the right place at the right time to evolve, or rather not evolve, the way it did. The telltale sign of the galaxy state lies in the ancient globular clusters of stars that swarm around it. Globular clusters are tightly packed spheres containing thousands to millions of stars, which were all originally born at the same time out of the same collapsing molecular gas and dust cloud. Massive galaxies tend to have both blue-looking metal-poor and red-looking metal-rich globular clusters. Astronomers refer to all elements other than hydrogen and helium as metals. That's because hydrogen and helium were the elements created directly out of the Big Bang 13.82 billion years ago. While just about all the other elements on the periodic table, the so-called metals, were only created during the lives and deaths of stars. Two possible exceptions are lithium and beryllium, considered metals even though tiny amounts were created in the Big Bang. Astronomers believe those globular clusters that look red are believed to have formed as the galaxy itself formed, while blue globular clusters were brought in later as smaller satellite galaxies were cannibalized by larger, more massive ones. And that's why NGC 1277 is so interesting. It's almost entirely lacking any blue globular clusters. One of the study's co-authors, Michael Beasley, also from the Institute of Astrophysics in the Canary Islands, says he's been studying globular clusters for ages, but this is the first time he's seen a galaxy with such an entire lack of blue clusters. So the red clusters are the strongest evidence that this galaxy went out of the star-making business long ago. The lack of blue clusters suggests that NGC 1277 never grew any further by gobbling up surrounding galaxies. By contrast, our own Milky Way contains about 180 blue and red globular clusters. And that's partly due to the fact that the Milky Way is continuing to cannibalize other galaxies that get too close, like the Sagittarius dwarf galaxy and the Large and Small Magellanic Clouds. But it's a remarkably different environment for NGC 1277. You see, this galaxy lives near the centre of the Perseus cluster, which, as we said, is packed with over 1,000 other galaxies. The thing is, NGC 1277 is moving so fast through the cluster, at some 3.2 million kilometres per hour, that it can't merge with other galaxies, collect stars from them, or pull gas from them to fuel star formation. As well as that, the region near the centre of the Perseus cluster is so hot, interstellar gas can't cool into molecular gas and condense to form new stars. NGC 1277 was identified as unique in that its central supermassive black hole is far bigger than it should be for a galaxy of this size, some 1.7 billion times the mass of the Sun. That compares to our own Milky Way galaxy's black hole Sagittarius A star, which is about 4.3 million solar masses. All this reinforces the scenario that supermassive black holes and the dense hubs of galaxies tend to grow simultaneously. But NGC 1277's stellar population stopped growing and expanding because it was starved of fresh material from outside the galaxy. The authors have 10 other candidate galaxies to look at, all with varying degrees of arrested development. And next year's launch of NASA's James Webb Space Telescope will allow astronomers to measure the motions of the globular clusters in NGC 1277. And that'll provide the first opportunity to measure just how much dark matter this primordial galaxy contains. You're listening to Space Time. I'm Stuart Gary. A new study has discovered that all galaxies rotate around their galactic centre once every billion years, regardless of how big they are. The surprising findings, reported in the monthly notices of the Royal Astronomical Society, will allow astronomers to better understand the mechanics of galactic physics. One of the study's authors, Professor Gerhard Meurer from the University of Western Australia, says while it's not Swiss watch precision, nevertheless, regardless of whether a galaxy is very big or very small, if you could sit on the extreme edge of its disk as it spins, it would take you about 1 billion years to go all the way around. Meurer says by using simple maths, he was able to show that all galaxies of the same size have the same average interior density. He says that means you won't find a dense galaxy rotating quickly, while another with the same size but lower density is rotating more slowly. Meurer and colleagues also found evidence of older stars existing out to the edge of galaxies. Based on existing models, astronomers had expected to find a thin population of young stars at the very edge of the galactic disk. But instead of finding just gas and newly formed stars at the outer edges of their disks, the authors also found a significant population of older stars, along with a thin smattering of young stars and interstellar gas.
What it actually shows is that to first order, and there's always a little bit caveats here, to first order, all galaxies have this same density interior to their outermost radius that you can see. So that's the same thing as saying they have the same orbital time. It says they have the same average density. Now, inside that average density, you have some galaxies where the whole galaxy is more or less at that average density, and those tend to be what we call dwarf galaxies, small galaxies. And then the spiral galaxies, the average density is that value, but as you go in and closer to the center, the densities get higher and higher.
You still have the same conservation of angular momentum then as
Yes, that's right.
Yeah. Tell me about your research. How did you do it?
Well, it was a bit of we did it through, you're looking at 3 different surveys of star-forming galaxies. But I guess I should say that the genesis of how it came about, how we first noticed it, is with one of those surveys. And it's been something that I've been doing now since, I guess it's around the year 2000 I've been working on this survey, but about 5 or so years ago, I was trying to follow up on someone else's results that said that galaxies use up something like 20% of the gas supply in one orbit, one orbital time, or one dynamical time. And so I tried to check that, and I found out, hey, they got all the same orbital time. That was kind of weird. And then after a while, I found different ways to plot that and checked it with other samples. And so I ended up with 3 samples of galaxies, although there's some overlap between the samples, and 3 different ways of measuring this outer radius in galaxies and finding this consistent result. And the consistent result being that they have the same orbital time at this outer radius. But what that means is for a given parameter that we have for measuring the mass of the galaxy, which is this velocity parameter, for this given orbital velocity, the radius scales with that linearly. So the bigger it is, the faster it's going around. And that's just like in the clock analogy. If you have like 2 clocks, a big clock clock and a small clock. The second hand of the little clock and the big clock, at that tip of that second hand for the little clock, it'll be going much slower than the big clock, where it has a longer second hand. It'll be going much faster at that tip of it, and so that's the size versus the tip velocity is linearly related.
That's why they like to launch rockets from near the equator.
Yeah, that's right. That is related to that. You want to launch near the equator because you already get a little boost up in the velocity. And likewise, at the pole and at the equator, you'll both go around the whole Earth in 24 hours. But, if you're like standing at like the North Pole with your hands outstretched, then the velocity of the tip of your finger is a lot smaller than if you're standing at the equator with your hands stretched straight up, and the tip of your finger is going much quicker. So that's the same kind of linear radius velocity relationship. It's the same angular velocity, so it takes the same amount of time to go around, the same orbital time. And that's why the clock analogy sort of works pretty well, because it's something going around and the same time. We found that the rotational speed of the galaxy is linearly related to the size of the galaxy at its maximum extent. And what that means is, the bigger the galaxy, the faster it goes around, but the angular speed is the same, which means the orbital time is the same. And then through some simple maths, you can show that means they have the same average density. And I think all that is pretty inescapable conclusion. The meaning of it, I think, is debatable, how it came to be that way. But I give the best interpretation I can of that meaning.
We're 27,000 light years from the galactic center of the Milky Way. It takes, about 240 million, 250 million years to complete one rotation. So we can pretty well extrapolate that then to mean that other galaxies at similar densities, if they had planets at that distance, would also take about the same amount of time.
That's right. Yep. The same interior density. And it also means that we're roughly a quarter of the way out to the edge of our galaxy, because we're going around, quarter or third of the way out, going around 240,000 or 270,000 years.
One of the interesting things about this was your ability to actually work out where a galaxy ends. And that's pretty cool, really, because I was always of the opinion that these things just sort of taper out into nothingness, but there's a finite ending to a galaxy.
Yeah, and this is causing a bit of controversy even amongst astronomers. And there's a couple of caveats, a little caveat to this. This is where a part of the galaxy ends, which is the disk. And that disk is itself embedded in a halo of dark matter. And we have reasons to believe that goes out much further, like 40 times further. And with that halo of dark matter, there's also a thin smattering of stars that also goes out to some similar sort of distance, about 40 times this distance.
And globular clusters too?
And globular clusters will be in with that as well. Yep. So these halo populations, they're not rotating with the disk, and the halo is not rotating with the disk.
That's Professor Gerhard Meurer from the University of Western Australia node of the International Centre for Radio Astronomy Research. I'm Stuart Gary. This is SpaceTime. Scientists have detected what are called equinox cracks in Earth's magnetic field. The March equinox occurred a week ago on March the 21st. Equinox cracks are a phenomenon caused by the Russell-McPherson effect. They occur in the weeks surrounding an equinox when fissures form in the geomagnetic field, allowing the solar wind to pass through the magnetosphere's protective shield, triggering auroral displays at higher latitudes. The effect is caused by opposing polarities in the solar wind and the Earth's magnetosphere, which can partially negate each other. Although these cancellations can happen at any time of the year, they tend to be stronger at the time of equinox. Interestingly, previous studies have shown that the March equinox is slightly more geomagnetically active than the equinox in September. I'm Stuart Gary. This is SpaceTime. US President Donald Trump is looking at establishing a United States Space Force, a new branch of the military focusing on space warfare. It follows the drafting of the National Defense Authorization Act legislation by the House Armed Services Committee, which was designed to create a Space Corps within the US Air Force. But the Space Corps legislation was opposed by the White House and the Defense Department, and so didn't make it into the final bill. The president described his new strategy while addressing an audience in San Diego, saying it recognizes space as a warfighting domain, just like the land, sea and air. The Space Force would most likely relate to the US Air Force in the same way as the US Marine Corps serves the Department of the Navy. The whole thing's happening because there's growing concern in Washington over reports of a possible Chinese development of a so-called space navy. This is SpaceTime. I'm Stuart Gary. America's newest and most advanced weather satellite has been successfully launched into orbit. The United Launch Alliance Atlas V rocket carrying the GOES-S spacecraft blasted off from Space Launch Complex 41 at the Cape Canaveral Air Force Base in Florida. The Atlas V was launched in its 541 configuration, equipped with 4 strap-on solid rocket boosters and a Centaur upper stage.
Status check.
Go Atlas.
Go Centaur.
3 seconds before launch, the powerful RD-180 engine will ignite.
Everything is go. T-minus 15 seconds and counting.
9, 8, 7, 6, 5, 4, 3, 2, 1. And the liftoff of the Atlas V and NOAA's GOES-S, a highly sophisticated weather-watching eye in the sky, to join its twin in providing better forecasts and saving lives.
Atlas has begun a pitch and yaw maneuver to steer to its planned path, an azimuth of 100.7 degrees.
At 35 seconds, the rocket carrying GOES-S will reach Mach 1, traveling faster than the speed of sound.
Down, right on schedule. Signatures look good. Roll program is complete. The speed chamber pressures are rolling off as expected.
47 seconds after launch, the vehicle will pass through the area of maximum dynamic pressure, or max Q.
Max Q.
This is the point when mechanical stress on the rocket reaches its peak because of the rocket's velocity and the resistance created by the Earth's atmosphere.
Booster has throttled up as expected.
You are also hearing the voice of United Launch Alliance flight commentator Marty Malinowski.
SRB chamber pressures continue to look good and plateaued.
At 1 minute 50 seconds into flight, the first 2 solid rocket boosters will be jettisoned, followed about a second and a half later by
burnout.
Other boosters.
And we have indication of SRB burnout. Booster engine continues to perform well. To SRB jettison.
And a clean separation being reported of the solid rocket boosters.
The next major milestone, 3 minutes 30 seconds into flight, the payload fairing protecting GOES-S during its flight through the atmosphere will be jettisoned 3.5 minutes after launch.
Booster has throttled down as expected. They have the RCS power valve activation at this point. System is pressurizing to flight levels. Signatures look good. Booster has throttled back to 2.5 Gs.
10 seconds away from payload fairing jettison.
And we have good payload fairing separation and CFLR jettison.
And we have a good payload fairing jettison, exposing GOES-S to space for the first time.
And booster has begun to throttle to 4.6 Gs in preparation for BECO. Boost phase cooldown is underway. Logo pyro valve has been fired.
The call BECO stands for Booster Engine Cutoff. That will happen at 4 minutes 22 seconds into flight.
Boost phase chill down is complete. And we have BECO. Shutdown looks good.
6 seconds after BECO, the Centaur second stage will separate from the Atlas booster.
PN2 purge firing. The RCS is underway. We have ignition and full thrust on the RL-10.
And the Centaur single-engine RL-10C engine ignites for the first time. It produces 22,900 pounds of thrust.
Our steering has been enabled. Fire rates look good.
This is about a 7.5-minute burn of the Centaur RL-10C engine. This is the first of 3 burns of the Centaur main engine.
Burn altitude is 129 miles. Downrange distance is 701 miles. Current velocity 13,903 miles per hour.
The GOES-S satellite will be placed in what's known as the GOES West orbital position, covering the American west coast all the way to Hawaii and Alaska. Once in its final position, it'll be renamed GOES-17. GOES, by the way, stands for Geostationary Operational Environmental Satellite. The GOES-S is the second of 4 new generation weather satellites being placed into geostationary orbit. The first, GOES-R, later renamed GOES-16, was launched in 2016 and placed in the GOES East position, covering the continental United States and US Atlantic coast. The GOES satellite constellation is operated by NASA and the National Oceanographic and Atmospheric Administration, NOAA, America's Weather Bureau. The 5,142 kilogram spacecraft built by Lockheed Martin will provide higher frequency weather observations with greater accuracy and resolution. This will allow faster, more accurate and more detailed data in near real time, enabling forecasters to track storm systems, lightning, wildfires, coastal fog and other hazards. The spacecraft are based on a Lockheed Martin A21008 platform with an orbital life of 15 years. Its science instruments package includes an advanced baseline imager to observe Earth's weather, climate and environment, a lightning mapper, a solar ultraviolet imager for observing coronal holes, solar flares and coronal mass ejections on the Sun, an extreme ultraviolet and X-ray irradiance sensor to monitor solar irradiance levels in the upper atmosphere, a space environment suite to monitor proton, electron and heavy ion fluxes in geosynchronous orbit, a magnetometer to study the space environment magnetic field, which controls charged particle dynamics in the outer regions of the magnetosphere, as well as transponders for search and rescue distress signals. I'm Stuart Gary. This is SpaceTime. SpaceX has carried out the 50th launch of its Falcon 9 rocket, placing a new telecommunications satellite into orbit. The mission from Space Launch Complex 40 at the Cape Canaveral Air Force Base in Florida carried the Hispasat 30W6 Spanish-language telecommunications broadband satellite into geostationary orbit.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition, liftoff. Pitching downrange. Stage 1 propulsion terminal. Vehicle is supersonic.
Falcon 9 is passing through the period of maximum dynamic pressure.
Vehicle is experiencing max Q.
Heard the call out. We're now experiencing maximum dynamic pressure where the velocity of the first stage and the density of the Earth's atmosphere combine to create the greatest loads on the rocket. Through that period, Merlin engines have throttled back up to full power. Propulsion indicates nominal. Power and telemetry also reported nominal. Next major activity just a little under a minute from now. We'll have the main engine cutoff, followed by stage separation and ignition of the second stage engine. Trajectory looks good. We're going right down the middle of the track.
Eco. Stage separation. Recognition.
We've had a good first stage shutdown, a stage separation, and a good ignition of the upper stage engine.
Fairing separation confirmed.
Good payload fairing separation. The fairing separating into the two halves and falling away. We're coming up on 4 minutes into flight. GNC reports trajectory is good.
Acquisition of signal, Bermuda.
Acquisition of signal Bermuda indicates that the Falcon 9 telemetry is also being acquired by our ground tracking station in Bermuda. Falcon 9 continues to go right along the planned path, heading east from Cape Canaveral into the first of 2 orbits planned for this evening.
Built by Space Systems Loral in Palo Alto, California, the 6-ton satellite, the size of a bus, is the heaviest payload ever launched into geostationary orbit by the Falcon 9. It's equipped with 40 Ku band, 10 C band and 6 Ka band transponders, providing television, broadband and telecommunication services across Europe, the Americas and northwestern Africa. Unfavourable weather conditions in the North Atlantic Ocean recovery area downrange from the launch pad prevented SpaceX from attempting to land the Falcon 9 core stage following its delivery of the satellite into space. Interestingly, the mission carried a second, previously undisclosed DARPA research payload for the United States Department of Defense. The experimental package was jettisoned from the Hispasat 30W6 satellite following its release. A secondary payload orbital delivery system, or PODS, was developed by Space Systems Loral for the deployment of the classified mission known only as PODSAT. PODSAT is thought to be part of the DARPA Phoenix project, being developed by NovaWorks in Silicon Valley to develop a system to allegedly harvest valuable components such as power supplies or antennas from old non-functioning satellites, using a highly advanced transponder-equipped robotic arm. The Falcon 9 first flew back in 2010, getting taller and more powerful ever since. The latest and most powerful version, the Falcon Heavy, which combines 3 Falcon 9 core stages mounted side by side, was launched on its maiden flight last month. Last year's busy manifest saw a record 18 launches involving Falcon 9 rockets, more than all other American launches combined. I'm Stuart Gary. You're listening to Space Time. And time now to take a brief look at some of the other stories making news in science this week with a science report. Scientists have discovered that while most children as they age into adults gain more neurons in a region of their brain known as the amygdala, kids with autism spectrum disorder have an unusually high number of neurons early on and then appear to lose neurons as they become adults. The findings, reported in the Journal of the Proceedings of the National Academy of Sciences, are based on post-mortem analyses of brain sections from 28 people diagnosed with autism and 24 neurotypical individuals. All of the subjects were aged between 2 and 48 at time of death. The amygdala is a small almond-shaped region of the brain associated with emotion control, regulating anxiety and social interactions. It's a unique brain structure which usually grows dramatically during adolescence as teens become more socially and emotionally mature. The number of neurons in one part of the amygdala was found to increase by more than 30% from childhood to adulthood in neurotypically developing individuals. But kids with autism had far higher numbers of neurons in this area. And as these kids grew older, the numbers of these neurons declined. Scientists speculate that having too many neurons early on could contribute to anxiety and challenges with social interactions. It creates a sort of information overload, a thriller in the amygdala, as Amy Farrah Fowler would say. It's possible that over time, this consistently high level of neuron activity could wear on the system, leading to some neuron loss later on. Israel has finally confirmed that it was behind the 2007 attack which destroyed Syria's atomic bomb program. The attack by squadrons of F-15 Eagle and F-16 Falcon fighters on the night of September 5, 2007 ended plans by the Iranian-backed Syrian dictator Bashar al-Assad to develop a nuclear weapons program. The Israeli attack, known as Operation Orchard, was the culmination of 3 years of intelligence gathering by the Mossad and the IDF Intelligence Corps, which collected the evidence needed to prove that Assad's regime was secretly developing a nuclear option with the help of North Korea. It's worth noting that Pyongyang's also been helping Iran develop its own nuclear weapons and missile programs. The evidence showed that the Syrians had developed a gas-cooled graphite-moderated reactor designed to produce weapons-grade plutonium for use in nuclear bombs. The facility, disguised to look like a farm, was built near Deir ez-Zor, located some 450 kilometres north of Damascus. The reactor was connected by a pipeline across the northern desert to the Euphrates River. Israel was always suspected of carrying out the attack, and some of the details of the operation were leaked by former CIA operative Edward Snowden. It seems Jerusalem had contacted Washington before carrying out the operation. In 1981, Israeli warplanes carried out a similar attack on an Iraqi nuclear weapons facility being developed at the time by strongman Saddam Hussein. The Iraqi program also famously included development of what was described as an atomic cannon. The world's last northern white rhino male has died. The 45-year-old rhino named Sudan was part of an ambitious effort by Kenyan Conservancy to try and save the subspecies from extinction after decades of decimation by poachers on behalf of the Chinese medicine trade. Sudan was being treated for age-related complications that had affected his muscles and bones and caused extensive skin wounds. Doctors were forced to euthanize him when his condition suddenly rapidly deteriorated. The death of this last male rhino leaves only 2 females of this subspecies alive in the world. The only hope now left to save the species from final extinction is in vitro fertilization, which in rhinos is not always successful. Rhino horn is marketed as an aphrodisiac in Chinese medicine. However, multiple independent scientific tests have proven that it doesn't work, other than being a quick way to remove money from gullible people. Scientists have discovered key proteins in platypus milk which have the potential to fight deadly superbugs. Researchers with the CSIRO detected unusual monotrine lactation protein structures with unique antimicrobial properties that appear to help kill bacteria. The platypus is already a very strange creature, a venomous marsupial with a duck bill and a beaver-like tail. And because it's a monotrine, it lays eggs and hatches its young outside its body. But the mother then lactates milk to feed its young through a mammary pad on its abdomen. Scientists at Deakin University isolated the proteins in the platypus milk as part of their study of lactation among monotrines and marsupials. SpaceX and Tesla CEO Elon Musk is the latest high-profile name to delete his Facebook account as the fallout continues from the Cambridge Analytica case. The problem is the public doesn't seem to understand that people providing social media, or search engines for that matter, aren't in the business of providing a service to the public. They're in the business of providing personal data on people. Their likes, their dislikes, their habits, what they purchase, where they live, who their friends are, the websites they visit, and their political views. With the details, we're joined by Alex Ahara-Reut from IT Wire.
Look, it's very true that social media platforms and even search engines like Google and Bing and Yahoo are using their ability to watch what you're doing, monitor what you're doing, collect information about you, and then use that information and sell it. And there's a famous saying that says, look, if you're not paying for something, then you are the product. And never has this been more clear than here in 2018, where an ex-employee of Cambridge Analytica spilled the beans on the sort of information that was being able to be garnered from people who originally were simply answering a personality quiz if readings of the reports have made it correct. And, interestingly, this is the sort of information that I've read that Facebook was collecting back in 2010, and they've been comfortable with this whole time. It's only since they were caught and this was exposed that suddenly, if we can't be trusted with your data, we shouldn't have it. Now, Facebook themselves, they have a facebook.com/safety page, and you can read there about stuff for parents and bullying prevention and online well-being, and they also have a privacy section. But, the reality is that even if you're surfing the internet, you have a Facebook account, even if you're not a Facebook member, then people can be tagging photos and you're in those photos. Facebook can be collecting information about you even if you're not a Facebook user. But often you go to websites and you see the ability to comment using the Facebook platform, or Facebook has got some sort of like an invisible bug that it offers people to put on their sites. And Facebook can track you around the internet, looking at things that you're surfing and viewing. And it's when you see those ads appearing in different parts of it, some way that's done by ad companies not connected to Facebook. But this information is being captured by lots of companies, not just Facebook. And this is where, there's a couple of excellent articles online. One's from a company called trustedreviews.com. It's a well-known tech website, and they've got an article just from the last few days, March 21st, and it says Facebook privacy settings, 18 changes you should make right away. And there's another article from a website called techlicious.com. It's like delicious, but instead of DE, it's techlicious.com, and they have an article from March 20, and it's got the complete guide to Facebook privacy settings.
What are the tips you would recommend?
Things like privacy checkups, where you can look at all the apps that you have installed. So you can click on settings, but there's also a thing called apps a bit further down the page on the left-hand side. And in apps, you can see the apps that have access to be able to put notifications in your feed, or to see all of the different things that you share in terms of who your friends are and all the different likes. But there are a bunch of different settings that allow you to determine who can see your posts. Is it everybody? Is it friends of friends, or is it only you? And there are a myriad bunch of different settings.
Alex Zaharov-Reutt from IT Wire with that report. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download Space Time as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from SpaceTimeWithStuartGary.com, or from your favourite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, @Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.